The most important AI security story right now isn't some jailbreak screenshot. It's a trust model failure in a real agent workflow. So Google disclosed a critical vulnerability in the Gemini CLI and the run-gemini-cli GitHub Action with a CVSS score of 10. That is absolutely insane, which are affecting a ton of different versions that I'll link below in the comments. The core issue was that in headless CI environments, Gemini CLI automatically trusted the workspace folder for configuration and environment loading. In untrusted workflows, that could lead to remote code execution via malicious content in the local .gemini directory. Google also fixed a second issue where --yolo mode ignored fine-grained tool allowlists. I think that matters because this is not a story about the model deciding to misbehave. It's a story about attacker-controlled content being accepted as trusted configurations inside agentic runtimes, with code execution reachable before the sandbox even comes up. Novi's write-up is blunt about that, and I think they are absolutely right to be blunt. Here's the primary source facts that we've seen. Google's advisory says that Gemini CLI in headless mode used to automatically trust workspace folders for the purpose of loading configuration files and environment variables. In a CI setting, that processes untrusted repository content, and that is an incredibly serious problem. If an attacker can get malicious content into the workspace, for example, through a pull request or other untrusted input paths, the agent can end up loading attacker-controlled content configurations before normal trust checks or sandboxing even apply. Google explicitly says that in these conditions, the issue could lead to remote code execution via malicious environment variables in the local .gemini directory. The advisory also describes a separate but related problem in older versions of the Gemini CLI with a --yolo flag. It ignored fine-grained tool allowlists in the settings file. So if a workflow handled untrusted input and allowed something like run shell command, the policy layer could be much weaker than the operators thought. In version 0.39.1, Google changes the policy engine so allowlists are evaluated even with the --yolo flag. The patches are released. I'll release all the patch notes in the comments, but the action release landed on April 24th, and Google's release notes show a new trusted guidance doc arriving in that release. Novi, one of the accredited research teams, published its public write-up on April 29th. Their framing is useful because it emphasizes what the exploit actually is. It's not prompt injection. It's not the model spontaneously doing something weird. It's an infrastructure level trust failure where attacker-controlled content was silently treated as trusted configuration and then executed on the host system before the agent sandbox initialized. So they also argue that cross-affected workflows, host-level code execution, could expose whatever secrets or credentials or source code that the workflow could reach. Google's own trusted environment documentation now tells users to classify workflows by data trust level. If you're interested, check out some of the videos I have on data trust leveling. I talk about that in excess in a few of my videos where we really need to identify the different trust levels for the input and the output of our model. Google's using this by setting a environment variable, so only after making that trust decision, then you should start applying least privilege to GitHub tokens and credentials. Prefer maintainer triggered workflows over automatically handling untrusted forks, and keep allow list as narrow as possible. Ideally using native read or search tools instead of using the shell when it's feasible for your platform. That combination of advisory, patch, and new guidance makes the underlying lesson here very clear. And that technical lesson is that the security boundary for AI agents is usually not the model by itself. A lot of the public conversation around agentic security still over-indexes on prompt injection in the most narrow sense. Can a model be tricked into following bad behavior? And that problem is real. But the incident is a reminder that some of the highest consequences failures happen one layer below that. Here, the dangerous path was untrusted repository content entered the CI workspace. The agent runtime treated that workspace as trusted for configuration loading, and the host ends up executing attacker-controlled behavior before the system's intended safety boundaries even start doing useful work. That's structurally similar to some of the older supply chain and CI/CD problems. The novelty is not code execution through configuration as a category. The novelty is that the AI coding agents now sit inside of those workflows with broad ambient authority, extra configuration surfaces, tool policies, and human operators who may assume the main risk is model output instead of the workflow trust. The -- YOLO details matter for the same reason. If an operator thinks that they have constrained an agent with fine-grained tool allow lists, but a change made effectively nullifies that control, then their mental model of the safety boundary is wrong. Google's fix is significant precisely because it restores alignment between what users think the policy says and what the runtime actually enforces. That is why I think this story crosses the threshold for disclosure, I guess. It is not just a bug in one product. It is a public failure of a trust model that many teams are going to reproduce unless they became much more explicit about trust inputs, configuration loading, execution rights, or all of this in the agentic system. The deeper point is that agent security is composition security. An agent is never just a model. It's a model plus prompts, files, local state, environment variables, tokens, shell access, repo contents, CI triggers, approval rules, and workflow permissions. If any one of those layers silently upgrades untrusted input into trusted authority, the whole system can fail, even if the model itself is behaving exactly as expected. That's why the line from Novi, that this is an infrastructure level execution before the AI system ever had to reason, is so important. It cuts against the common industry instinct to narrate every agent failure as a prompt injection story. Sometimes the real problem is more classical and far more dangerous. Confused trust boundaries around where infrastructure and configuration come from. It also says something important about how AI exists in the CI/CD ecosystem. Once you put an agent into a pull request review or an issue, code modification, or any workflow that touches untrusted user input, you have effectively put a probabilistic orchestrator into the same blast radius as your supply chain tooling. That does not mean you shouldn't do it ever. It just means that you need to engineer those workflows like hostile environment infrastructure and not like some friendly autocomplete. Google's guidance now effectively says the same thing in operational language. Decide whether the data is trusted. If it's not, harden the workflow, minimize privileges, prefer safer native tools, and only then enable workspace trust. And I think that's the right frame to think about. If you build or deploy agent workflows, there are a few practical key takeaways here. First, stop treating repository content, issue text, pull requests, and local workspace files as morally different from executable input. In an agent system, those surfaces can become control surfaces. Second, make sure you trust explicitly. If your workflow runs on untrusted data, require an affirmation trust boundary. Document exactly where that configuration can load from and from where and under what conditions. Google now requires that decision to be visible through an environment variable, which is better than silently trusting everything in headless mode. Third, apply least privileges aggressively. Minimize GitHub token scope, minimize cloud credentials, and narrow tool access. Google's own guidance recommends using native tools like read file and grep search rather than casually running shell commands. That advice is incredibly boring, but I think it is very correct. Fourth, verify your policy control means what you think they mean. The -- YOLO fix is a great reminder that an allow list on paper is not the same as an allow list actually enforced at runtime. And 5, threat model AI workflows as supply chain infrastructure. If an agent touches code, CI, secrets, or deployment adjacent systems, then the right reference class is not just chat safety, it's build system safety. The cleanest lesson from this bug is simple. The model is often not the security boundary. The real boundary is the harness around it. That what files it trusts, what configs it loads, what tools it can call, what permissions it inherits, and whether untrusted content can cross those boundaries without a hard stop. Google's Gemini CLI bug matters because it's made Google's Gemini CLI bug matters because it made the failure visible in a very public way. And if teams learn the right lessons from it, they will stop asking only whether their agents can be jailbroken and start asking the important questions. What exactly does a system trust before the model even runs? My name is David Campbell. Follow me if you're interested in learning more about AI security and AI safety.